Hey guys, I wanted to make a video showing how I've learned to model things better in Fusion so that things won't break as often, which has been important when making the bow scissors. Maybe this will help teach you some new tricks. If you aren't as familiar with this kind of parametric modeling, I hope this video shows you how cool this kind of software is. And if you're already an expert on 3D modeling, then hopefully this video is a good insomnia cure. Anyway, I usually start by just messing around, not thinking too much. Eventually, I might end up making something that looks good, but if I change things, stuff breaks. But just like making things in the real world, making it the first time teaches me how to make it better the second time. So let's remake this knife with what I've learned. And I'm not actually going to make this a real knife, it's just an example for the video. The first thing I'll do is save a new file. Next, let's make some parameters. We have these Zen pins in the bow song, and we need them to hit in just the right spot. I want the angles of the handles to be the same whether it's open or closed. So how do we do that? Well, if everything was straight, the handles would turn 180 degrees. But we have some other angles going on. I made these handles have a 2-degree taper. We'll call this handle angle. And there's a 1-degree angle between each handle. I'll call this gap angle. So the swing angle will be 180 minus the handle angle minus the gap angle, which is 177 degrees. And look, that's how much it's swinging. So how do we actually use this though? Let's make a sketch. This will be our pivots. This will be the Zen pin with the handle down. And all these numbers are me just kind of making up stuff. Measure values you like to get a better idea of what might work. And this is a guess where the Zen pin moves. Now let's draw another circle. Now we add a line, and we add the swing angle. This is our base sketch for the bally. Now we can make the blade. So let's make a new component and a new sketch, and project some of that geometry we created. The actual hole in the blade will be bigger if we're using bushings. I'll draw a center line. We're only going to make part of the blade. You want to keep your sketches simple, and we're already going to get a little complicated on this one. Now we can draw where the Zen pins contact. We don't want to make the same exact arc, or it won't fit. On the bottom, I made it contact a flat edge. Again, this is for teaching. I'm not saying this is the only way to do it. I added another circle. All it does is help me remember not to make something that the Zen pin can bump into. Okay, that looks good enough for now. Let's extrude it. 0.125. Symmetric. The whole length. This will keep it centered on the origin, which will make things easier later. Actually, let's go ahead and make the blade thickness a parameter too. And pop it back in. I probably won't change it, but it'll be nice to be able to use it later. Let's add a little radius here. And mirror it. See, I could have mirrored in the sketch, or put that radius in the sketch, but we want to keep the sketches simple. I could have also put these radii in the sketch, but at that point it'd get harder for my brain to imagine how it would interact with the Zen pin. So, you gotta find a balance with these things. Actually, let's add one more thing. The washers will be 3/8. Will that be a problem? It looks okay. We can mess with it later. Now let's make the actual blade. New sketch. I could use this new face I've created but I try to use the origin when I can because I'm less likely to have sketch plane errors if I change something. Make sure you stay in the same component so your sketches stay organized. Okay, here's where it's just your own artistry and what you like in knives. I extruded it using the 2 object setting on both sides. I didn't think it looked quite right, so I tweaked the bottom a bit. Hopefully this won't be a problem later. Time for the bevel. I'm going to create a plane along a path at the very tip of the knife. Then I'm going to make a box with a hollow grind shape. Now I'm going to use that to sweep a cut into the blade. Alright, that didn't really work, so I adjusted it. That's better. Let's change the appearance to stainless steel. This looks okay, but I want more control over the plunge line, and I don't want to have to manually do it to the other side. I'm going to change the sketch so it's flat on top. Then, let's make a new body instead of a cut. Let's extend it out a bit. Now, let's make another sketch, and just make a box where we think it might end. And we'll cut through everything except the actual blade. Now I can add a radius to this new body. And we're going to mirror the body around the origin. Then combine cut both sides. It worked, but the plunge line isn't where I want it. Let's scooch it down. Okay, I like this. I'm trying to make it like a choil or something. I don't really know what I'm doing. I ain't no Ken Onion or Gary Garlic or whatever. Let's add a couple more radii. Maybe 30th out here, an inch here. And we can even sharpen it if we want. Do a chamfer, distance and angle, 20 degrees, or I guess 70 degrees. Okay, looks good. Now, when actually machining things for manufacturing, some things you probably don't want to actually model, like engravings or threads or little edge breaks. So I'm going to suppress the sharpening. When you're done with the blade, you can group everything on the timeline together like this. There's one more thing on the blade we can talk about though. Notice the seam in the middle of the bevel. If I do a zebra analysis, you can see a corner. These curvature combs flip, the ISO curves are different. For 99% of people watching, this is totally fine. It doesn't matter. You can do whatever you want with it and it'll be great. But there are more than one ways to model the same thing, and depending on what you're making, this could be important. Let's go back to the curvy blade sketch. Let's make these construction lines and make a control point spline. Now, I'll adjust the spline to try to get the same curve. Alright, that's good enough. When you're happy, you can fix things in place if you want. But some stuff broke. Most is easy to fix, but we did lose our reference plane for this sketch. I'll just make that an origin plane. Delete all the fake projected geometry and make a new box. And again, you can just fix things in place or dimension them however when you are happy. Now I can cut through and redo the radius. And I'll fix the sharpening too. Okay, so now there's no seam. And we don't have that same zebra corner, and the other curvature tools look good too. Again, you probably don't need to worry about this unless you're machining some super crazy finish. Check out Name Not Importance videos for more info about the quality of different surfaces. Let's make the handles. We leave the blade component and make a new component. Now we make a sketch inside of this component, picking up some of the geometry from that base sketch again. Draw a center line. I think the top of the handles is going to be like 0.385. I'll make some tangent lines centered on that. Now we can add the handle gap angle, but we're going in the middle, so we divide it by 2. And we add the handle angle. I'm going to go ahead and add the screw holes to the same sketch. Let's make the pivot a parameter so we don't mess it up. We can change where we use it. See, if we make it its own geometry instead of just the projected sketch, we could add different tolerance if we want. Now what was the screw head? 262. We'll add the screws later. Let's add some room. This isn't supposed to be a tight fit. I also know the size of the washers, so let's add those too. And the thickness. Now we extrude. But we want to lift up by half the blade thickness and the washer thickness. Or we could set it to extrude from this surface and just add the washer thickness. Next is the counterbores. I forgot the size of them. I guess I'll make that a parameter too. You don't have to do all of these parameters. Let's make the handles titanium in a cool blurple anodized color. But it's not actually titanium. Its physical material defaults to steel, so it's too heavy. Let's change it to titanium. At the end, we can check the weight and see if we need to change the design. The reason I made it blocky is to show off lofting easier. Let's make a couple sketches. I want a smooth arc on the top. Often things work better when you create a bigger shape than what you're cutting. Now we copy the geometry to the other side, but with a smaller arc. Now we can use these two sketches to cut away geometry that transitions from one to the other. That's what lofting is. This would make manufacturing more difficult, so you have to be careful when adding this kind of feature. But this is just for fun. Now let's round the ends. I want the bottom to be a little sharper, but I'll still round the corners. I could make the corner 0.125, but if I were making this, that would mean a tight fit when making the fixture for this part. If I make it a size that isn't the radius of a common end mill, like 0.15, then I could use a 1/4 inch end mill and get through the corner easier. Let's add some slots. I can use the offset tool to make the slots follow the shape of the handles. It's a little hard to see. If you hit Shift N, it'll make all the parts different colors. I'll add some arcs to the end of each slot. Whoa, that's not right. Let's see how it looks with a chamfer. Not quite. How tight is this corner? Again, here's where I'd want to be able to use a 0.125 end mill. It looks like I can go a bit smaller. Let's just add a reference dimension to the sketch. Okay, that'll be tight, but it'll work. Oh, I almost forgot the Zen pins. Let's cut with the original sketch. Both ways. We'll probably need a fractional size, plus a little extra. Looks like I'm breaking through. How about 5/16? I'm not going to remember that. Yes, you're cooler than me if you live in a metric country. Leave me alone. Let's group all the handle stuff. Okay, now we can finally see if our math worked. Right now, everything can move around. Let's ground the blade so it can't. Now let's do an as-built joint. Go on this surface and hold Control to click the center of the pivot hole. Now, we don't want it to fully rotate, so right-click and edit motion limits. Set the max to swing angle. If you click things in a different order and it's not working, you might have to do minimum and a negative swing angle. But hey, it worked. Okay. See, the handle's still floating because it's an as-built joint. Now we need a mirror of this handle. And we can do another as-built joint. If we do a motion link, when one handle moves, the other will too. But we have to make one negative. Alright, everything looks good. Let's add the next two. They aren't different parts, so just click one of the handles and copy-paste. And we'll do a regular rigid joint. Match up the bottom holes, flip it, then offset it by the blade thickness plus the washer thickness times 2. Same thing with the other one. Now we can adjust things, and all of the handles will update. We've got even gaps, the Zen pin holes line up. Now we're going to actually flip the handles around and capture the position. This will make it easier to make the handle spacers. New component. On this sketch, I'm going to keep the dimensions to a minimum. But I'm going to make a bunch of reference dimensions. Now we can see if things are too thin or too close. I could actually dimension the spacer based on the blade, but I find this is another case where Fusion can get easily confused. Plus, this is a situation where you might not actually want things to be parametric. Let's say you already actually made a bunch of spacers in real life. Then you realize you think the blade needs to be 1/10 shorter. The spacers would still work fine, so you don't want all your spacer fixtures and things being updated for a change in geometry that you didn't need. But still, if you do change the blade, then you'll want to check manually that there's no issues. Let's make it titanium. Maybe a different color. Let's add some gimping. I only want it to cut through the spacers. If you wanted it on the handles, then you could have done this earlier and the geometry would just get projected when you make the spacers. Now let's pattern it. This keeps the sketch simple. I have to click an axis. But because of the handle taper, we can't do it in one step. I swap back and forth between spacing and extent to get numbers that I like and can remember. Now I can do the other side. I don't like how it's cutting off the radius. Okay, I like this more. Now we can do another rigid as-built joint. We don't need a mirror of this part, so we can just copy it. Now we can add a joint. We could just find and pick the angle that looks right, but if we figure out how to get it with our parameters, then it'll stay the right angle when we update things. Looks like it's 180 plus our handle angle plus our gap angle. Now we can flip the handles back around. Capture the position, then group all these parts on the timeline. Let's make a new component for hardware, which maybe you don't have to do at all, but it's good just to check things. I'll explain why at the end. Let's start with what we can't import from McMaster. So we'll make a bushing component inside the hardware component. And I'll sketch a circle. Make it bronze if we want really accurate weight. Now we go back into hardware and copy paste it. Next is the washer component. Same stuff. Extrude to washer thickness. Copy and paste the rest. Okay, let's make a pivot. I don't have one right in front of me, so I'm just going to kind of make it up. Now let's make a center line. We'll do the same screw head height and diameter. I think this looks okay. Now we can revolve it. You could put a hole in too if you want. I wouldn't model the threads though. It's not necessary. Now we can put them where they go. Lastly, we can import some screws from McMaster. Find the size you need. Yeah, I think that's what I was using. Get the step file. This does have model threads. Man, importing all those screws for the April Fool's video really slowed my computer down. Let's place it. Actually, I think I need a longer size. We can use the section view to look inside. Yeah, let's go longer. Edit undo. Let's go to 1/4. Copy paste. Now you can delete the group for the McMaster part so that you can group all the hardware stuff together. Alright, we're done. I like having all the hardware together because we can just hide it when we don't need it. Or we can even go back in the timeline so it doesn't slow down our computer. Let's add the sharp edge back. Now we can render it or whatever. We did it! Oh wait, I forgot the Zen pins. What length? 1/8 inch, 5/16. Let's do this. Step file. Same old, same old. And now we can see the pins are going to the correct positions. Let me regroup everything. Now, if I didn't screw anything up, we can see how much the whole thing weighs. 4.3 ounces? That sounds plausible. I also like making a sketch to check the overall dimensions. We should see if my parameters actually worked. Bwah, bwah. I guess there's something wrong with these tangent relationships. Okay, that fixed it. Let's try changing it again. Same thing. That's not hard to fix, but maybe we can make it better. What if I change where my blade sketches meet? Like this. Seems good. This radius got a bit confused though. 1 degree. Okay, now it's good. Does the pin work? Yep. 3 degrees. Yep. How about the gap angle? That seems to work too. What if we change the blade thickness? We didn't keep our sharp edge. Maybe I'll change the sketch. This is kind of silly, but I think this works more like how it should now. Now that I have something fairly clean to work with, I can actually use this for future designs. So I copied it and deleted some things I didn't need. Now we have a base to work with. But I don't want to make a knife. I want to make a trainer. So I copied the base and made lots of changes to it. I had to make some bigger changes, so some things kind of broke and had to be redone, but nothing was that bad, and by working off the base model, it took me less than an hour to make this trainer, whereas the original knife took several hours to make. I hope you found this interesting. Maybe I'll continue this series and show how I do the cam side and actually machine this trainer. Or maybe I could do a follow-up video where I get some of my knife making friends to critique and modify this design, and we could talk about tolerances and things. Let me know in the comments what you guys think, and I'll see you next time. Bye.